Okay, so we have a pentagon, a regular pentagon. When we're trying to find the area of a regular anything, we always start with the formula. 90 equals 1/2 of the apothem times the number of sides times the side length. Okay, well this is of course a 1/2, 1/2 there. It's just a not pretty one. So we always start with 1/2 of a times n times s, and we solve for a and s. So half of 5 is 2.5. So I divide both sides by 2.5. And I get a times s equals 36. So now I have a decision to make. There are two variables, and I can only solve for one at a time. I have the apothem variable, and I have a side length variable. Now it says approximately what is the perimeter, which means I need to keep my side length. So I need to replace my apothem. Okay, so from our trig equations, we can find that apothem equals the side length divided by 2 times the tangent of the trig angle. So that's s divided by 2 times the tangent of, in this case, 36 for a pentagon. Okay, the angle is always 360 divided by 2 times the number of sides. That's a times, not a subtraction. So I replace the apothem with that value. I still have my s, I still have my equal sign, I still have my 36. All of that is still there. So now I have to continue solving this algebraically. So I have s times s is s squared over 2 tangent of 36, and that still equals 36. So I multiply by 2 tangent of 36, both sides. Let me move over here. We're going to round it to 2 decimals at the end. So I have s squared equals 52.311. And then the final thing to find the side length is take the square root. So the square root of 52.311 is 7.23 is the side length. Okay, and because I want perimeter, I'm going to times that by 5, and that will give me the perimeter of this pentagon, which is 36.16 inches for the perimeter.